done it like 3 4 times. So so you get the same thing there. I gotta give him credit for higher. I gotta give him credit for higher. They knew him from he gets to go I mean, yeah. So you don't need to set up That'd be nice, you know. It's the first time. No. Either I've never liked it at all. Yeah. This 2 years I was this
Nice objects.
here's the
Make it more like that. Like the stroke administration is kind of crazy.
You're now saying that they still have some.
Hi, good evening everyone. Thanks for coming. We've got a couple of very exciting exciting talks for you this evening. But before we get into it, our standard announcements. So first of all, we are recording today's session, so if you can please turn off your cell phones, put them on silent. Restrooms are out and to the right if you haven't figured that out already. What else? We have GDG DevFest coming up November 17th. Tickets are already on sale. You've probably seen the link, and if not, we'll be sure to follow it up with an email. The agenda is still TBD, but it's going to be 2 tracks of pretty amazing talks that cover the latest technology. So sign up before it gets sold out. It's been sold out for the last 3 years and going. Thanks, Fish. And I think with that, I will open it up to announcements. Anyone have announcements? All right. I guess not. Kevin, do you want to give us a quick overview of Google announcements yesterday?
So how many of you saw the announcements yesterday? Anyone? Yeah, a bunch of you. So what I thought I would do, I'm sure many of you are mildly curious about the Google Home stuff. So I was going to do a quick, just Q&A, anyone who has questions. But I know about half of you didn't see the announcement. So there's a 1-minute video. I'll play that really quickly. And if you have any questions, I'm happy to answer them, and then we'll jump into the main event. Yes, I am. I've been on the Chromecast to living room to now the home team for over 3 years. So, and the hardware is about where that all started is 10 feet from my desk. So I'm very much in the middle of it. So here we go.
I can do both. So did someone post the live stream viewer? Did you post the live stream viewer on the video page?
Okay, Google, turn on the hall lights.
Okay, Google, turn up the music.
Okay, Google, what's a good substitute for cardamom? Mix together equal parts cinnamon and nutmeg.
Okay, Google, what sound does a whale make?
Okay, Google, what's the weather?
To be with stream.
How do you say nice to meet you in Spanish?
Encantada de conocerte.
Okay, Google, dim the lights.
Cool. So, does anyone have any questions? Anyone? Yeah.
What's the maximum response time, and how does it compare to other products like that on the market?
So the question was about response time, and I guess you're asking for the response time from when you make a request. The maximum is dependent on the microservices behind it and how long they take, but it's fairly reasonable. Those kind of questions are hard for me because I've been using it for 9 months now, and it's improving every day. So, but it's pretty reasonable. And then it has a lot of contextual type stuff. So as you ask a question, you can ask a related question, and it kind of has the context. Yeah. Everybody hear me okay? Yeah? Yeah.
Is there an API to add other things to it? The open API?
Yeah, so we announced the IFT support, IFTTT. And so in my living room, if I walk in and say, okay, Google, turn on the lights downstairs, or make the lights red, or whatever, it does all that. And so part of that is through sort of out-of-the-box sort of first-party integration, or third-party integration through Philips Hue, but then also like changing the color is done through IFTTT. Yeah. And then on the, like we're launching, on the audio and music and video kind of partners, we have a few launch partners that have tight integrations there. And those will go out, and then soon, I think this year, we'll open up the SDK for others. Yeah, yeah.
Extended to this question, so such a compare with the other products such like Amazon's Alexa.
You know, they're all similar times. I mean, it's I've never timed the two or anything like that, but I can tell you that it's like a reasonable response time. Not instantaneous though. Yeah.
How effective is it to ambient noise, especially when you are playing something on the TV and you issue a command?
Yeah. So the question was how well does it work with background noise? I can tell you it works very well. So the microphones in it are far field mics. And so there's like a mic array in there listening, but it's not like the mics in your cell phone. It's a far field mic. So it's an expensive microphone versus the one in your camera that is not. So it's designed for doing that. And you know, I have 3 kids at home. You guys have probably seen them, and my house is very loud, and I never have trouble. I also have one of them sitting a ½ inch in front of my TV, and while I'm watching TV, I can speak to it and don't have any trouble, but I speak very loudly. So. Yeah?
Oh, so in the video, it mostly shows how it works with the lights. Does it support other appliances as well, like your microwave and your fridge? The other question is, since you mentioned that you have at your home set it up, how much it costs to set it up, with all the lights and
Yeah. So the question was about like lights and how does that work and how much does it cost, things like that. So to start with, so out of the box, there is integration with just a handful of partners that's direct. So that being SmartThings from Samsung, Philips Hue for their lighting stuff, Nest. But then the one that's most important is IFT, which is IFTTT. And IFTTT is a service that integrates with like 100 different items. And so you can handcraft your own voice commands and then pipe those into anything. So be it Wemo, their stuff, be it coffee makers, be it air filters, washing machines, all that through IFT. And so typically, like for myself, I've used IFT for a long time, that I have an ARIA scale, and when I take my weight, it sends it to IFT, and then IFT will put it in a Google spreadsheet. And that's the kind of thing that IFT does, and so it's something that just connects things of various systems together. Price-wise, I don't know, the Google Home, I think is $129, someone, yeah? I've never bought one. So it's $129. I don't know. Lights, if you want lights, they're I don't know, $100, give or take. And then adding more lights is usually like $20. Yeah.
Does it have concept of like profiles or voice recognition? That if I say in the morning my agenda for the day, the light says my agenda for the day, would it know how?
Sure. So the question was about multiple profiles. So understanding my voice versus Ria's voice, or my wife, or my kids, or what accounts can be on it. So today it will launch with just one account, and it doesn't really do anything different versus whose voice it is. But that's in the near future. I'm guessing this year, but that's a bit more of a guess than anything. It's based on the roadmap stuff of what folks are working on. So that should be able to tell different people. I actually don't know, like, there's lots of follow-up questions about security and things like this, and I have no idea. So, yeah.
Is there any integration with Sonos or Wi-Fi music software?
integration through Sonos would be through IFT, but I don't know if they're on it. I don't know if they are or not. I don't think there is at the time through Sonos. I mean, that would be, do you know if they're on IFT? I don't know. I mean, there's so many, you open up IFT and it's like overwhelming. I'm sure there's over 100 integrations. Yeah.
If I'm on Project Pi, can I use it to like place a phone call, for example? Can I link to my Google Hangouts account and make a call?
So currently there isn't like that kind of voice, I don't know, whatever that's called, conference calling functionality. So the question was about using Google Home as a conference call. Yeah.
What about things like telling your phone to text something to so-and-so saying such and such?
I will give the same answer because I don't know if you can, I actually don't know if you can do that with Google Home. Like there's a lot of commands and things that it does, making animal noises and all these things, and reminders, and I've never used any of that, so I don't know. But I have wrote an IFT recipe that says, hey Google, where's my phone? And then basically IFT will tell my phone to launch Spotify and play a song.
At max volume.
So it's, so can you know, I don't know, IFT is like a pretty cool thing, so like a commercial for IFT. Yeah.
We do have a plan to support the seamless the listening within the rooms because of people moving around, so room to room. But when it comes to multi-devices in the room, kind of seamless listening toward the direction of the people moving around. Because I'm using the Alexa. Whenever I'm using Alexa, I need to stop doing something and then ask Alexa. But the people actually moving around in the home.
So the question
listening
seems to be
within the
about
room, yeah.
voice commands while you're walking
Moving around,
from room to room.
Yeah.
I have no idea.
Do you have any kind of plan to cheaper edition of that, like Alexa did?
Little pods.
To put those devices to every room.
I definitely can't talk about future ideas, but that's a great idea.
Great, thank you.
That's a very good idea. Yeah. Rita, how long should I wrap it up?
Yeah.
Yeah, cool. So I'll possibly be around afterwards. I'll be around afterwards till 8:45. So if the talk's done by then, feel free to grab me in the back. Cool, thanks.
Thanks, Kevin. We have one more quick announcement before we get to the main talk.
Hi, my name is Don Hayden. I'm an entrepreneur in residence at the Founder Habitat, which is a Stanford-based incubator, and I'm looking for possible early-stage startup engineers interested in early-stage startup related to machine learning, augmented reality, and believe it or not, fashion. Thank you very much. I'll be at the back.
Thank you. All right, and now welcome Eitan to the stage. Eitan is the engineering lead of Tango, and he's here to tell us more about what he and his team have been up to. Eitan.
All right. Turn this on. It's on?
Yes.
Perfect. All right. Let me set up real quick. How's everyone doing? Good? Okay. It's Wednesday. This is always a pain. All right. So do I get lucky with this? Wow. That's awesome. Okay. So, my name is Eitan, and I work on Tango here at Google. I lead our developer tools group. And before I start talking about Tango and what it is and kind of give a little bit of an introduction, how many of you have heard of Tango before? Oh man, we're getting really good. Okay, so for the basics, I'll move relatively quickly, but I'll try to focus on some updates and then maybe give you guys a chance to ask me some questions. To maybe kick it off, Tango is really about allowing smartphones to have an understanding of the space around them, teaching our phones to sort of see and understand the world that we're in. And we're actually pushing this out in products really very shortly. And to give some context for this, this is a promotional video that we made. It's just a 30-second spot, but it kind of shows what's possible. Can you hear the sound? So, it's really about bringing hardware and software together to enable experiences that blend the virtual and physical worlds. And on Tango, we add special sensors to mobile phones. So we add a wide-angle camera and also a depth sensor. And we fuse the information from those sensors to track the position and orientation of the phone as it moves through space, as well as to get information about the geometry of the scene. There are 3 core technologies that we provide through Tango. So the first is motion tracking. That's understanding the space and moving through it. The second is area learning, which is the memory of the device. And the third is depth perception, which is this geometry that I'm talking about. To go through them in a little bit more detail, so the device is actually using the wide-angle camera and inertial sensors within the phone and fusing them together, tracking points in the world that are fixed to back out the position and orientation of the device. So as I hold my Tango device up, yes, it's big, it might recognize, okay, that exit sign in the back. And as I move, it sees the perspective on the exit sign change, and it also gets information from the accelerometers and the gyroscope. And by fusing that together, it's able to know, whether I walk 2 steps forward or 2 steps back, and also whether I rotate. Depth sensing is what gives the device its understanding of the world around it. So we've got a time-of-flight camera on this device. And what that does is it sends out a pulse of light, and it actually times the phase shift of the light going out. It gives you an idea of the distance from the device to, say, the floor in front of me or to the podium right here. And with this, you not only get an understanding of one single frame, but you can fuse it with motion tracking to build real-time meshes, essentially, of your world. And when you have that, you can do things like placing virtual objects in the physical world and blending them correctly with reality. So you've got occlusion. If I put a virtual object behind this desk, I can actually move on the other side of it and see it. And then there's area learning. And area learning is about taking Tango devices into a space and teaching them what that space looks like, so that you can have sessions that exist over multiple days or that combine multiple phones together. So again, if I look at that exit sign there, that might be a feature that I recognize in my environment. I showed the device my room, and then I turn it off. And I turn it back on, and it says, hey, I've seen that exit sign before. And furthermore, I can share that with other Tango devices, so we both see the exit sign and we know our relative position to it. And that allows us to have multiplayer experiences, like multiplayer games, and also to do things like indoor navigation. So the big selling point, like augmented reality, I think is something that's been pitched before. And the big selling point for Tango is that we are markerless AR, and we can provide 3D positional tracking, environment capture, and precise indoor location without any augmentation of the existing environment. So you don't have to put tags down, you don't have to put beacons in place. You just walk in with your phone, turn it on, and kind of off you go. And this is launching. I mean, this is not the stuff of tomorrow. This is actually the stuff of today, which is crazy. So we will, I don't think we've announced officially the day, but very, very shortly we will be launching the Fab 2 Pro. Lenovo is the first OEM that is producing Tango phones, but we're in talks with many more, and we're going to follow up with other phones as well. So you'll start to see different form factors for Tango phones in the future. To give an idea of some of the contents, these are, I guess, 6 applications that we showed off at Lenovo Tech World, which was an event this summer where we first unveiled the final hardware for the phone. And they fall into a couple of different categories. So the one is we're saying, you can use your smartphone to do more in the world. You can use it to take measurements. I know that when I moved recently, I lost my tape measure, actually, and now, if I could just use my phone instead to take measurements of the environment, so that's pretty powerful. Or if I go to the store and I want to buy, a new couch, and I want to ask my girlfriend at home, like, will it fit? I could, take a measurement of the couch in the store, send that to her, and she could project it into the environment. We're also working on being able to scan that couch and get a more accurate representation of it, so we can do that too. And then if you think about buying furniture for your home, maybe you're not even going to the store. Friends of mine bought a table recently, and I also bought a sleeper sofa, and both of us made terrible, terrible mistakes. And so with Tango, you can actually just see at the correct size and scale in your environment what a couch or a chair or a table or a globe looks like. You can actually get the products that you're buying. You can also use smartphone AR to play in new ways and to have experiences that change based on the environment you're in. So the 2 here that we're showing is, one is Raise, which is this virtual pet. So you've got a dog and he shows up in your house and you put a bowl where he's supposed to eat food, and he kind of like follows you around. And depending on what environment you're in, the experience is a bit different. And then the same with dominoes. So you can go and make domino rallies on your table, like going to chairs or down the stairs, like in the video. And it's just a much more interesting and expressive way to play with your environment using your digital device. And then the last one, the last category, is really using Tango to explore. So this is, you walk into a mall and you want to go to a specific store. GPS doesn't work so well indoors. Wi-Fi localization is not what you'd want. And so we have very, very precise indoor navigation capabilities. Or envision walking into a museum and going up to a picture, instead of your audio guide, maybe coupling that audio with visual aids as well that are just displayed on top of the environments that you're in. And one particular case of this that's interesting is the American Museum of Natural History wanted to do more than just allow people to go to the museum. They wanted you to be able to bring an exhibit home to you. So they built, I'm told, scientifically accurate models of dinosaurs. They have feathers, and we don't know exactly what they look like, so that's their representation. But you can see the correct scale of a T-Rex or Velociraptor next to each other in your room. And then something unexpected happened, which is that we discovered that Tango can also be used for AR selfies and sort of new expression in digital media. So we built this application that was supposed to be, I mean, it is a nice educational application, but then people started doing stuff like this instead. And so I think that there will actually be new medium of expression for people using Tango for computational photography and videography and augmenting the world and sharing sort of that augmented version of the world out with your friends or family. So Tango, in a lot of ways, is kind of like GPS. It's something that is a new sensing mode that we're adding to phones. And when GPS first came out, people didn't really know what they would do with it, but now we kind of take for granted, like you can just get directions anywhere. You can find your way within like vast cities, and we sort of take it as a given that you will be able to get directions from one place to another. I can't actually remember the last time that I planned out a route before I went somewhere. And if I really think back, it wasn't that long ago, like maybe 10 years ago for sure, I was definitely like planning my route, and now I just take it for granted. And with Tango, we have the opportunity to extend this. So instead of just getting to this building and then having to look at a map for a conference room, you can get to this building and actually have an augmented arrow guiding you to a conference room. Instead of going to the store and kind of looking around for that troublesome item or having to ask someone where it is, you'll just pull up your phone and it will show you. And I think all of the use cases that we've kind of explored and put out there today it's really just the tip of the iceberg, right? Like, we're still kind of in the state where we don't know what the full potential of this technology is. I think we have a couple of use cases that are compelling, but just like with GPS, I think it will be used for things that we don't expect. And that's really just to reinforce this message that sensor innovation can also result in app innovation. And we really have to hit the tipping point where we can get these products at scale into consumers' hands, but then there's tons of creative developers, some in this room, out there, who can take advantage of this technology, leverage it, and really push the boundary of what's possible with these applications. And so that's what we're really excited about. Yeah?
Aside from the special sensors that you add in, does it require a high-end cell phone for processing capability, or is there cloud assist or pre-computation?
Yeah, so Tango, for the most part, actually exists on device. And it can work on kind of mid to high-end mobile CPUs right now. So the CPU in the Fab 2 Pro is actually a Qualcomm 652 Snapdragon, which is actually their second. The 820 is sort of like the top of the line, and then the 652 is one step down. Yeah.
Can you describe on there what the lenses are and what we're looking at?
Yeah. So on the left, I guess I'll point here because it's easier. So you've got in the middle, this is a wide-angle camera. It's a fisheye lens. And this is really important because it makes our tracking system robust. We get a wide field of view of the world, and we're dependent on seeing some features, some textures, right? So in the extreme case, like the worst case for Tango is think of like a spherical white room, right, with no features and no texture. Actually, humans get confused in those situations too. It turns out that we rely on some of the same cues that Tango does to get around. But this makes us robust to, say, a white wall kind of looking like a spherical white room, right? Because we have a wide field of view as opposed to a narrow field of view. Above that is a depth sensor. Well, actually, first is a flash, and then is a depth sensor. So that's the time of flight camera, sending out that pulse of IR light. Above that is an RGB camera. And we know the relationship between all of these sensors, so we can transform data between them, and that's how we create like the nicely composited image of the world. Wow. Okay. Yeah.
So how far the object resets, wide camera resets?
So the time of flight camera has a minimum range of, I think, 30 centimeters for the time of flight, and a max range of around 4 meters. It degrades with depth, though. So, it falls off the further you get. Yeah?
What kind of hit on the battery are you getting?
So, I believe that the motion tracking capability alone takes 250 milliwatts.
Can you please repeat the questions?
Yes, I can. So the question was, what kind of hit on the battery are you taking? And we pull about 250 milliwatts for motion tracking. So it is battery intensive. If we were targeting 3 hours, I believe, of continuous runtime if you were just to run okay, I'm going to take questions at the end. All right, I'll take one.
Just one quick question. How do you address privacy concern?
Yeah. So we are fortunate.
You already know us very well. Now we carry your phone.
Yeah. So the motion tracking capabilities all stay on the device. There's no cloud component to it. For the indoor location capabilities, there are ongoing discussions about how we'll treat it. I think the most likely model is like Google Photos. So you choose whether you want to share an area description of a certain environment, just like you would choose to share either a photo or a video. And you may be able to go to public places, like say you walk into one of our partners, Lowe's store, and they can say, okay, the area description of this store is public to you. But it will be treated, the same as we would treat any other private information. So yeah. All right. So now I do want to talk a little bit about the future and kind of where we're going with this, and I'm just going to play another brief video. So this is research that we're doing on top of Tango right now. This is kind of the next 6 months of where we're going. So, some of that stuff is further looking, but we believe that Tango is applicable outside of just phones. And one of the nice things about phones is we actually reduce the cost of a lot of these sensors, and we make them available in fields like robotics, or you saw some work on the space station as well. Over the next short while, we're hoping to do some enhanced museum tours, roll out our indoor localization program, and then I'll try to leave more time for questions, so I'll go through this quickly. But you can also make location-based games like Pokemon Go work indoors with Tango, which is cool. Okay, so I guess my call to action kind of for you guys is, help us change the world. If you're interested in Tango, or if you're a developer, we're always looking for passionate people who have ideas, who are interested in building in the space. It's really just the beginning, and I think it's going to be an interesting journey. So now, questions. This is a link to our developer documentation, and yes, I know there are lots of questions. Okay, let's start with you.
So how good are your cameras in low light?
So the cameras are fairly good in low light. Well, the depth camera is actually excellent because it's infrared. The other cameras do, have auto gain, and they try to compensate for low light. Of course, if you turn the lights off, Tango tracking does not.
Do you have special processing for that, or are you using the normal image processing?
So the wide-angle camera is a little bit special in that it's globally shuttered, which can help a bit. But we're not doing anything too special. Yeah.
Since the depth camera is infrared, you can use it to make pictures in the dark.
Yeah. So the question was, since the depth camera.
You can come.
Yeah. Also, you can come up to maybe make a line from the mic. Yeah. But the question was, since the depth camera is infrared, can you take pictures in the dark? You can take, I guess, depth images. Yes. You can. Yeah.
You just mentioned an indoor localization program. Can you expand on that?
Yeah, so our area learning capability allows you to localize very precisely indoors. And we're working with a number of partners. Lowe's is one, but we're also working with a number of museums to do trials of what indoor navigation with a Tango device might look like, as opposed to, say, BLE beacons.
So only for certain points.
For right now, yes, though the capabilities are on the device. So if you're interested in trying it out and seeing how well it works, you can learn your own area description of, say, your home. It stays on the device. It doesn't go to the cloud. It's just stored on the device, and then you can localize to it. Yeah?
You just mentioned beacons. How well does Tango work with them in terms of using the beacon data to provide a...
Yeah, the question was, how well does Tango work with beacons? Can you use beacons to make Tango better, to make beacons better, that kind of thing? So right now, there's no explicit integration between Tango and beacons, but I could see that actually as a really interesting use of Tango to do things like survey, signal strength and accuracy of your beacon placement. It's an interesting use case, but it's nothing we've done explicitly. Yeah.
What kind of software are you using for the overlays, like OpenGL or Unity or AutoCAD?
So that's a great question. We have native support, so C++, that would be OpenGL. We have support for Java, which is just normal Android development. We have support for Unity, which makes it really, really easy to get up and running with Tango. And we also have support for Unreal Engine as well, which is another really popular rendering engine. Yes?
Okay, do you guys have anything that's with skeletal tracking? And if you don't, do you plan to, and how easy do you think it would be
Yeah.
to be done on Tango itself?
All right, the question was, do we do skeletal tracking on Tango? The answer to that is today, no, we do not. The sensor data is there, but we've been focused very heavily on the positional tracking of the device, as well as 3D reconstruction of scenes. If you had built something, say for the Microsoft Kinect, to do skeletal tracking, you could port that to Tango sensor fairly easily. We're hopeful that that's something the community does. Actually. Yes.
Can you dive into the decision to go with like all new hardware, all these sensors added in, as opposed to using like existing cameras and doing like a monocular type slam type approach? Like, yeah.
Yeah, so Tango actually is monocular slam, so it's not using the depth camera to do at least the tracking. The decision to go with new sensors is kind of twofold. So one was we wanted to make sure that we could deliver something that was robust and worked well. And I think a lot of people have tried to do monocular slam on mobile phones, like on the iPhone or on higher end Nexus devices, with limited success. There are a few issues. One is the field of view, which really does make it hard to build truly robust systems. Another one is you require very, very precise timestamp information for all of your sensors. And the third piece is that we believe that the depth camera is significant. You can do the tracking without the depth camera, but when you think about placing an object into the scene, the depth camera is actually what allows you to do that, correctly and to composite it correctly onto the image. And so I think over time it's possible that we do take some of our learnings and our techniques and apply it across different hardware, but to deliver something today that worked well, we decided to bring both hardware and software together to make the problem as tractable as possible, because the fact of the matter is it's just really, really difficult to do this well and to bring it in a consumer device. And so we wanted to give ourselves an advantage to be successful.
Thanks.
Yeah.
How good is that point cloud accuracy? How it compares with Kinect Fusion, and how good is the SLAM trajectory?
Okay. So the point cloud that we receive, it's, I guess, a little bit different than the Kinect sensor, which was structured light. There are different trade-offs, but it should be comparable in terms of what you can do with it. Our meshing approach is very similar in some ways to Kinect Fusion. It's kind of like an extension of it, I guess. So you can expect similar or better performance there. And the motion tracking, we get about 1% error over distance traveled. So if I walk 100 meters in a big loop, I might be off by a meter in sort of our open loop motion tracking.
Also, a question: am I right that if I'm staying in a large room and I don't see basically the point cloud I can get is limited by the range of depth camera, right?
If you're standing in a large room, you are limited by the range of the depth camera. So if I stood, at one end of the room and wanted to place something on that wall, I would not have that information unless I had been there before and sort of seen it. Yes. Okay. Also, on time, how many questions? Last two. All right.
Okay, I understand this is targeted at indoor, but how well does it work outdoor and compared to, say, street view? And, for example, could you stick one of these on a bumper of a car and have it map out potholes on a highway and stuff like that and store them in the dimensions and everything like that?
Yeah, so there's kind of like good and bad news. The motion tracking and area learning actually works great outdoors. It turns out that outdoors there's lots of texture, and the cameras see that texture, and you can get a very, very good trajectory. With the depth camera, it's like not as good news because the sun turns out to be an incredibly powerful source of IR light, and so it can actually overpower the light being emitted by the camera. We've done some tests. It actually will work okay in shadow, but in bright sunlight, the depth camera does not work. But the rest of it does.
So actually, along with that, is it speed sensitive? For example, does it start to break down if you're traveling at too high of a speed? say on a scooter or something?
We can go at sort of like car speeds. Again, the advantage of the hardware is we have a globally shuttered camera, so we don't have to deal with rolling shutter effects for the wide-angle camera, which means that we can go pretty quickly. We took it on a roller coaster, and you can, yeah.
Still gets dizzy though, just like people if you wiggle around very, very quickly.
If you shake it very, very quickly, yes, that's true. But consistent acceleration, it's acceleration, it's not velocity.
So how long does it take to do area learning, and how does it vary with the size of the room, and how long does it take to relocalize once you've done area learning?
So area learning depends on, I guess, the size of your environment and kind of the quality of the coverage that you want. So for this size environment, I could probably build an area description in maybe, I would say 3 minutes, something like that, with decent coverage, kind of like walking. You want to sort of retrace your steps and get good coverage from multiple angles to allow the device to relocalize quickly, right? If I just show it, one particular place in the room, it will have trouble in other places that it hasn't seen, right? So you want to do enough to give it coverage. If you do give it coverage, it relocalizes like very, very quickly. The goal, it's actually not about time, it's about how much you move. So the goal is that within like a meter with a good area description, you should be able to relocalize. But this is something that we're continuing to push on and continuing to try to make better in some of the products. Okay, I think that is it. Thank you guys so much for coming out. Please, check out the phones when they come out. And yeah, take care.
Thank you, Leighton. Our next speaker for today is Cheryl Chen. She's a developer advocate at Google and is working on game products and machine learning. She's going to tell us a lot about images today. Cheryl.
Do we have machine learning experts out here? Like anybody? Oh, okay. Well, I've taught artificial intelligence to middle schoolers all the way to grad student level. So hopefully I'll be entertaining for you. And I brought a modest stack of business cards too up here. Just like that, and let me make sure everything is plugged in. So, everything is coming through okay, you can hear me okay? So I'll be talking about image understanding, how computers see and understand what they're seeing. Have people looked at any of these APIs yet? They've been blogged about and tweeted about. Anybody? Okay, great. More interesting things for me to talk about. I'm not getting. I'm missing that actually. Something's happening. Oh, there it is. Why is it? Yeah. Okay, I'm not going to mess with it. It's a little bit, it seems to be a little off. Let's try it. Here we go. Oh, great. All right. So I'm going to be talking about image understanding and what it means for machines to see, for machines to perceive like you and I see, right? My name is Cheryl Chen. That's my Twitter handle is @FFPaladin. My email, which is not on there, is Cheryl. It's just my first name at google.com. So if you have any questions, I really encourage you to email me if it doesn't get asked, and I'll be able to either answer it for you or route it to the person who can. I'm working for Google Cloud Platforms, but before getting there, I was working on my doctorate at the Expressive Intelligence Studio, researching AI in storytelling for games. I also did some software engineering work for YouTube Search, and I've taught for Stanford's pre-collegiate studies and all over the world. I've been to 5 different countries teaching about computer science and artificial intelligence. So this has been kind of this passion of mine throughout my whole life. In this talk, we're going to cover just an overview of machine learning to get a sense of how it works. And I'll show you the Vision API, and you're all really familiar with it. I mean, you've all used image search before, right? Everyone here? And it's basically taking that same technology and making it available to developers. We're also going to be looking a little bit at how the API requests are made, and then go over a couple of use cases for how people would be using these APIs. So a brief overview of machine learning, right? So here's one of my classrooms in Kazakhstan, one of my recent trips just a few months ago. And when I'm teaching these students are probably teenagers, I try to get them to think about things and exercise their curiosity, because artificial intelligence is a pretty heavy subject. So I ask them questions like, well, why do humans use base 10? Does anybody have any thoughts? And usually, eventually we get to the real answer is there's no way to know for sure, right? But these are questions that I want kids to think about. And I ask them, why do we have lives in games? And then I talk about how back in the day, you used to have to pay quarters to play games. You can't just download them from the internet or play them, right? Why is 0, 0 in the upper left corner? This is after I've taught them about visual graphics and how to draw circles and rectangles. And then even more fundamentally, why do we even have these computers? Because I want them to invent the future. I want to teach, to kind of raise this next generation of future inventors and creators. So I need them to be asking themselves these kind of questions. And finally I ask, well, what do you think artificial intelligence is? And so in order to get them to kind of invent from core concepts, kind of define it for themselves, I first ask them, well, in thinking of new technologies, what are things that humans do better? What are things that computers do better than humans? And what do you think they would say? Does anyone have any? Adding, search, memory, right? And then what are things that humans do better than computers? Pattern recognition. Yeah. So that you get a lot of answers from kids, and they're able to answer these questions quite easily. So you get things like memory, not getting tired, math, repetition, multimedia, searching for things. And then the things that humans are better, you get things like emotions, creativity, solving problems. And again, this isn't I'm not telling them there's a right or wrong answer. I just want them to think about it. I want them to be curious. Solving problems, being original, and then eventually I'll get something like eating and pooping. I'm trying to really push them to think, because the answers that I'm really wanting them to get, I'm trying to fish for these answers that I want. I want them to say language. Humans are good at language. Oftentimes, in most cases, humans are better at computers, right? Learning. This is where we get the field of machine learning, was that humans have this capability to moving. The whole research area of robotics is in how do we get computers to reproduce what we see around us, what we do ourselves. And so if they're not quite getting it, I show them this, and they all know what this is, right? They'll say, oh, this is captured, they've all signed up for things before. And they'll look at this and they'll see that. So here is what it leads you to. It leads you to the ability for machines to recognize. So this is the actual Vision API. This is the image. These images have been passed through the machine learning models that have been created by Google. And it's able to understand and score. It's seeing something. The machine sees that there are people running and has a score. Scores it's about 90.9980341.2%, or the probability is 0.99, certain that these are people running. And here we have the ability to detect or recognize facial expressions and detect text. And so as we're teaching machines to understand things, right, we are essentially using ourselves as the standard. Why is this necessary? Well, back in the day, humans had to route letters in mail. And machine learning gave us the ability to have machines process letters, process addresses, and route them correctly. And we were able to do this more effectively than actually and have less errors than when humans do it. And so everyone's heard of AlphaGo, one of the big buzzes of the past year. Again, we're using human behavior as a standard, and this is how I try to get students to understand how we are inventing, where do we need the improvements, right? And we use
human being as a common measure for that, even going back to the 1950s when Alan Turing proposed this test. And so last Thursday there was this big announcement about Google Cloud, and it's kind of a restructuring and understanding of where these tools are for people to use. So Google Cloud Platform, many people, most developers are familiar with. And then we have the Maps and Machine Learning APIs, and that's the section that we'll be talking about. Next we have the G Suite, so this is like Google for Work, emails, documents, calendars. And then finally, Chrome and Android, which is the platforms for which developers are using. And so Google takes their products, takes what they're working on with AlphaGo, takes what they're doing with images, and it tries to produce something that is useful to the everyday user. But then, on its way there, Google also takes apart the tools and the functionalities it's developed along the way and make that available for developers, and encouraging developers to continue on inventing forward. So, machine learning at Google. We know that there's like 60 products that are at Google that are using machine learning currently, and you can kind of see, right? These are all, Google Play, Gmail, Translate, Maps, YouTube. Here, you can kind of see over time how machine learning has kind of been this exponentially trending tool that Google's been using, and you can see it across the different areas, various areas listed here. AlphaGo, what we just talked about. And so, again, we're kind of hitting a really interesting milestone. Like, in my days of working in artificial intelligence, deep learning or machine learning was always seen as something that wasn't accurate enough or wasn't reliable enough to be used. And in the last year, we've just seen amazing progress that's been made, especially in the image area. And so this is one of the first APIs that Google has released for developers to use to build their own applications. And so here's some more examples. When I was working on YouTube search, we were using, we would have to be able to predict, what is a person looking for when they're searching? Are they searching for something specific? Are they searching for something in general? Do they even know what they're looking for? And then, of course, OK Google is now able to, similar to when I showed you how we're now able to read addresses off of mail, we're also now able to understand when people speak to us. We've all tried this with Siri on Apple or with OK Google on Android. And of course, combining two different functionalities, the ability to see something and understand something enough to translate it into another language. And there's over 90 languages of which Google is able to work with. This was originally, do you guys remember, this was actually April 1st prank. It was kind of a joke that Google was writing automated responses to your emails. Actually in 2009, 2010, I think one of those years, Google actually created this as kind of a joke. Oh, let's have AI respond to your emails for you. And then 5 years later, we actually have this functionality, and over 10% of users are using this machine learned responses to respond to their emails. And so, as I was saying, when I'm asking students, what do you think humans do better than computers? They list out off all of these functionalities, and Google has taken their attempts and the progress that they've made and broken it down to these APIs. And these are the first 4 direct machine learning APIs that are made available today. Okay, so let's talk about images, right? This talk is about what machines see. So when you see something, you know it's a kitten. If I ask, show me a kitten, what does it show me? Well, it's a fairly generic search. You get a lot of really cute kittens. But let's go even further, right? Because there's probably plenty of websites that are just kittens. You could just pull from one of those. What if you wanted kittens with bunnies? And these are, again, return results that, maybe that was easy. Maybe they were tagged. Maybe there was another website. So then I was like, let me try even more. Kittens with bunnies and ducks. And so it keeps going forward. Same thing. Kittens with bunnies and ducks and frogs. And so the idea is how is search interpreting what it is you're looking for, and how is it returning to you these results? Same idea. When I studied artificial intelligence, I worked with this idea of variation. So what if we made variations on this theme of kitten in a hat? Right? Kitten in a hat, sad kitten in a hat. Angry kitten in a hat. Right? And so Google is now, like, with these machine learning trained data sets, it builds models to help return these results, to help give meaning to this random collection, assortment of pixels. It's able to give meaning to that. Happy kitten in a hat. And it's literally, like, it quite literally looks like a bit of a universe, right? Outer space, and there's much more than just 3 dimensions, of course. But say we go into the animal section at the bottom, we kind of pull closer, and then there you go. It's kind of the knowledge graph representation of animals and cats. And so all of this is made available, even the demo here that I'll show you at the very end. And so that's like Google image search, right? Google Photos does the exact same thing. So try it on your own images, right? If you Google for French fries, and these are my photos, I'm a foodie, so I like to take pictures of food. I wonder if I go through my images, my photos, if anything weird comes up, I'm sure there's an explanation for that. And we search for, like, so that I was taking photos of you guys from the back. These are just my friends. If I look for, like, nature, right? Let's look for nature. These aren't tagged in any way, perhaps in location, but for the search results, they're not actually taking into account that for searching generically like this. Nature, or if I'm looking for bunnies. I have a friend with a bunny, so I took a picture of it. And for some, it's just like, here's a picture of a bunny I drew, or a Pikachu, which, by the way, is not a bunny. But for some reason, and so it's not perfect, right? People didn't know that Pikachu's actually a mouse. But at least it's consistent, right? Because back here in 2011, I have like a Pikachu figurine that's also categorized in bunny. So you can see that there's something, there's an aspect of learning property matching that's going on. And another one I can show you is, not text, text is another one. And so you can kind of see anything with text. Here's some receipts that I have. If you took a picture of a business card, let's say, and you wanted to go back and look for it in your phone, you're able to search for that because Google has trained its models to do that for us. Okay, go to this, okay. So yeah, I don't know, maybe it doesn't seem that hard to you, right? But there's like the space is quite large. You're exploring this universe, and you have to take these bundles of pixels and be able to categorize them, right? And you have to assign meaning. And so with our own naked eye, you can kind of see why a computer might be a little bit tripped up. Or this one, for example, if you're trying to figure out whether something is a mop, whether you clean the floor with it or you clean up after it, again, it's not so tricky, and so machine learning makes it possible for us to teach the computer how to narrow it down and how to make appropriate predictions, right? How would you predict apple from orange? How would you explain that difference? What is the meaning, right? It's very philosophical to kind of break down, like, what is the essence of being an apple? What is the essence of being an orange? And so machine learning enables you to do that by taking the raw data, the pixels, right? These numbered points of color, and it feeds it up to these artificial neurons, and it goes up to make a prediction finally as to what exactly is being represented in the image. And that's done after training the machine to understand, this is a puppy, this is a muffin, this is a mop, this is a dog, this is a cat, this is a bunny, this is a Pikachu, this is a bunny. But that's okay. So, and we understand not everyone is a machine learning expert. TensorFlow, you might have heard a lot of buzz about, is something that was basically free tools made available for people to build their own machine learning models. So if you're interested in optimizing your own machine learning models, then you would be using TensorFlow, and there's awesome introductory like Hello World programs to kind of give you a sense of what it is like, what it would be to kind of get started in that level of depth into machine learning. Actually the introductory Hello World example is a handwriting recognition example where you feed the machine, like it's trained on sets of of numbers, and so it's able to then recognize when something's a 2. Then we have, and these are again, we're going through all the different products, right? So you can build your own machine learning skills through here. Cloud machine learning is where we have the ability. So the technology that's training the models, like all the linear algebra that goes into training the models, it's basically fixed. All you're giving it is the data. So you're saying these are cats, or these are dogs, or these are muffins. And it's learning based off of your data. So you're passing data sets through it. You're not building you're not having to handle the mathematics itself, but you are able to at least create your own, train specifically for your use case or for your domain. And then finally, and this is what we're talking about, the more friendly machine learning is they're just APIs, and they're very simple REST APIs that I'll be going into in the next 2 sections. So, okay, the Cloud Vision API. So it's able to do the same detection that you're doing, that's happening in image search with simple REST requests. And these are the 6 main use cases that Google has released. Like these are the functionalities that are made available. You have the ability to detect labels, so you can. When I was typing in things like text and bunny, and when I was typing in nature, these are labels that have been assigned through the knowledge graph that Google's created through all of the information that's been passed through over the years. And then there's face detection, so we're able to understand a facial expression, that someone's face is in a picture, where their eyes start, where their mouth starts, where their nose is, like in Snapchat or in photo booths where you can put on fake glasses. It's using the same similar kind of technology. OCR, which is character recognition, and this is what's the word lens app, where you're able to look at a stop sign and then have it translate into different languages. That is using character recognition. Explicit content detection, and Google's just basically narrowed down these are the things that are considered safe and unsafe, and these are the different. There's a few parameters that they look at to determine that. Landmark detection, which is just looking at. You're looking at man-made or sightseeing spots, popular areas, and Google has marked the Cloud Vision API is able to detect and return, what this is and where it's at. And finally, logo detection is pretty self-explanatory, Coca-Cola or Disney or something can show up in an image, on someone's shirt, on a product, on a billboard, and the API is able to reason and return to you that this is what is being advertised. So making an API request is really pretty simple. You take this JSON file, and all the work is done here. You basically, this is where you represent the image, and then this is where you indicate what sort of functionality you want. So you want label detection, you want face detection, you put it here, and up here you can represent you can either point to an image, or you are passing in a 64-bit representation of the image file. Okay, so let's look at some of the responses, and of course we can do this live too, and I can do that if we have time. Here's an image, could be funnel cake, could be beignets, but it's identified as beignets. The MID, the mid, is just the ID that's represented from Google's knowledge graph. So this is just the representation, the ID represented there. And then the score is how certain it is that the prediction is accurate. And then the description is, of course, like what we as humans understand it to be. So it's kind of our label that we've given it. So you can see, I had to look up what a profiterole, how do you say that, profiterole? I had to look up what it was. It looked delicious. And of course, powdered sugar. Same thing with landmark detection, right? And it's even giving you the bounding boxes, which is how you get that need. It's able to impose that bounding box onto the image because it knows this is the information that it needs to determine that this is what it's looking at. It knows what city it is and the latitude and longitude of where this is at. And so these vertices represent, again, there's much more going on down there, but the vertices represent where in which it's identifying it's identifying. And then, you know, in terms of meaning, or at least it's grabbing some sort of definition or explanation of what it is, it looks to Wikipedia and is able to explain or narrate from Wikipedia on what this image is that is being looked at. Text detection, right? You can see on this boat that it says U.S. Coast Guard Auxiliary, and it has numbers on the side, and of course it's written up here. And it's able to not just, it's like the box is able to even tilt to adjust to the alignment of the text, and this works, you know, in various different languages. And so here are some of my teammates who have also been using these APIs. So here's face detection, and in face detection, it's able to look at, you know, properties of what the person is doing with their mouth, whether or not they're wearing a hat, and different coordinates of, like, you know, left eye. Right here you can see positioning written there, and also how they are responding. So if they're feeling joyful, and if they're feeling joyful, you know, how likely it is. So wearing headwear, right, likelihood, very unlikely. Whereas over here, it said wearing headwear, likelihood, very likely. And of course, you can kind of pull it all together. It's able to, it also draws, of course, color information, which seems pretty straightforward. And then, of course, okay, and as it's looking at the whole safe, unsafe parameters, these are the four flags that we have, the four things that are being detected. So we have spoofs, when an image is being altered to kind of be disrespectful or funny or inappropriate. Medical, like surgeries, are oftentimes like an unsafe thing to be looking at. Adults, I don't need to explain that. And violence, so anything like weapons, anything that looks violent. So, and so each of those is also the reason behind. Here you go. So this is what. So this is the basic. This is what it all boils down to. Really, really simple. You create the JSON request in the file that I showed you earlier, right? When I was showing you to put the image there, you can request with the image or image pointer. You call the REST API, and basically just post there, and the JSON response will then, it'll just return to you all the data that you receive, like on the sides here. Basically, these are the JSON responses that you get. So to look at particular use cases, right? Like as a company, I must detect adult content, violent content, spoof images, and medical content to protect my consumers and my brand. And so these examples, this is like one use case is to just filter out inappropriate content. Identify potential explicit content, manage large sets of images that are crowdsourced. Here's another one, sentiment analysis, right? As a developer, applications I build should be able to detect faces and emotional facial attributes and detect objects and logos. So again, this is able to detect a person's state, how they're feeling, and here is kind of an example of this in action. This was at, how many people were at GCP Next? You guys, some people, yeah. This is one of the big setups that they're using. This is called Emoto Booth. And so what it does is it takes a picture of you and it does the emotion detection and then paints the surrounding border, whatever emotion based off of color. So blue is sad, yellow is happy, purple is surprised, and red is angry. And so this is at least one like demo experience that was built to show this off. What do we have? Image metadata. So if you want to understand contents or landmarks, logos in an image, again, like there's thousands of everyday objects, right? But then there's also different landmarks, and whether they're man-made or natural, that Google can detect and give you information upon. Here's a tweet from, I believe Sarah on my team was working on. She posted this, and it's basically, it looks like the Eiffel Tower, but it isn't. It's actually the Paris Hotel and Casino. So it's so the tweet was very sassy. You think this is the Eiffel Tower in Paris? the Vision API isn't cool, here's how. And of course you go to that link, and there's a lot of photographers on my team. So when we're like working with these tools, we're like kind of testing out for ourselves. So he's been to Tokyo Metropolitan Government Building, and this is just us like going through for ourselves, just being like, wow, this is amazing how this is able to be so easily done. Like this is just a generic bridge. How does it even know, right? It's able to identify it as the Rainbow Bridge. And looking at receipts, if you want to extract information from receipts, invoices, and images, if you have some use for that. Again, it's like these tools are being made available, and like how we invent the future with that is up to all of us to figure out. But again, looking at, there's a lot of really useful things you could do with receipts. Like I even showed you with my own photo search, you're able to easily find receipts and identify them. And so here are a few testimonials that that have been popularly circulating. One from Sony AeroSense, where they're talking about how they're collecting so many images and now they haven't really processed it, and someone just saying, machine learning without knowing anything about it now. And so if you want to take a picture, this is the image to take a picture of. This is the slide. It's basically the grand summary of the Cloud Vision API that goes through these 6 things that I mentioned, and it's kind of pay as you go as you use it, and it's pretty simple to use. So I'll show you the live demos again. These are the 4 things that you can test out. This is kind of the spectrum. So we kind of saw it in the other order. This is like vision, language, speech to text, natural language. Some of these are still in beta. The middle part is the machine learning, where you're passing in your own data, and then TensorFlow where you're actually building the machine learning things. And so this is the whole spectrum. If you go to google.com/product/machine learning, I believe that was the link a few weeks ago, that might have changed, but if you look at the machine learning, you'll get a bunch of these links. So I was going to show the vision one. So you click on it, you get to this vision site, and it talks about powerful image analysis. And here I can just basically take an image, right? Here's one of my students, this one, and then I drag it in here, and then I click here, and it's able to already detect, so it's able to detect the faces, and then select the labels, so how it's identifying. You can also try this on your own too, if people with laptops want to try it out. That was the picture too. And a robot. And then, so in case of that, I kind of prepared a little bit. I have a slide breaker. So this is what you would have seen. You can try it. I don't know why it wasn't working in that moment, but you can see the MID is the ID for the knowledge graph. The description, it knows by just looking at it: education, profession, student, course. And so it's able, and then you can kind of see some of the properties just listed there. This is the older version of that. So you can see that image. And then you can also play, again, all of the models have these like short demos where you can try it out. And then the Vision Explorer. So I already have that up. This is the slide for that, but I wanted to show. Or actually, I have my own instance running that I can also run it too. But let's look at the Vision Explorer. And this gives you a sense of like the vastness. And a lot of the image data sets recently have been released. So we were looking at cats before, so why not look at cats some more? So here we have cats, like lots of cats. And it's like, what's cool is like, you really are going through a space of images. Like, you're traveling through. This demo is also online in the video. Underneath the food, so there's other reports food. This is going to be food, but this is like space. And if you wait, yeah, it looks like food and people. So this link is at vision-explorer.reactive.ai. The knowledge graph, which stores all of that information, I linked to just for show, and then the research. So this is a recent announcement that just happened on Friday, that they released data sets consisting of 9 million URLs to images that have been annotated with labels spanning over 6,000 categories. So if you're a data person, if you're into crunching data, this data set has also been made available on the research side. And then for those of you who are kind of curious about TensorFlow, here is the TensorFlow playground, where you can kind of play through and kind of add neurons, take away neurons, and kind of go through like the visual representation of what's going on when it's trying to classify and make predictions on data. And so that's a kind of a very, general overview of the image API. I could show you some more stuff too, but we want to leave some time for question and answer. So.
What is the scale of the human training that is required, and how is it arbitrated as to whether you get, say, false training in there that messes things up? Or?
So the question is about the level. How much did these models have to be trained, and whether or not there's how do we handle false training? Well, I think this is a pretty this is a machine learning problem that a lot of people have been looking at. I didn't work on so that's on the TensorFlow level, so I didn't work on that. I haven't really worked on much with it, but if you email me, let me put my email on this slide. If you email me, I can give you a better answer. There's all these, the concepts of training data and then testing the data and then proving the data to make sure that you're getting the correct results. So my email is cheryl@google.com. And I have business cards up here as well. So yeah, the whole idea, all these tools can be found. I don't know what links. So these are the links for that. Do we have?
Is the Photos app using this API, and if it is the all the information already extracted when you upload the photos, or is it done when you search for something with the each photo and using some API to extract it?
So as when you upload your photos to, when you upload your own photos to Google Photos, how's it doing? I don't. So that would be a question for the Google Photos team. I don't really have much of a guess on when they could do that. I think I would assume that they would do it as it comes out, but I would have to ask them.
Does any of those tools work on video files?
There might be something working with videos right now. Nothing that's public, but what people have been doing is taking screenshots from videos to make it work with image API.
Your APIs work with IoT-based hardware?
What'd you say?
IoT-based hardware systems?
IoT-based hardware systems? Again, that's another team, so I'm pretty sure that a lot of any devices that are using cameras, there was a demo, I can pull it up later, I can pull it for you later, but there's a demo of a robot that they've been building to kind of demonstrate how Internet of Things could work with image processing API and the training models.
So it's how you got the I'm not a robot checkmark, sometimes it pops up with all the identify the tree or go board. Is that the API message, or is it are you training it somehow? Or?
Yeah. I don't know. Again, I don't know for sure if that's what they're doing, but I'm pretty certain that it's as you're answering these questions with capture, with the images from Google Maps, it's able to store like the guesses and the answers that you're giving it. Whether it's being actually used to build the models, I'm not totally certain.
For Project Tango, has anybody used the Cloud Vision API to determine where they were, like say, in a public space, or let's say I was at Las Vegas.
Yeah.
I used my Tango device to look
Yeah.
around, to get information,
Yeah.
and would see the Eiffel Tower,
Yeah.
and tell me, oh, well, you're in Vegas, and
Yeah. Yeah, like anything specific to product team, I'm not totally sure about. But like this has already been used a lot with landmark recognition. So I think the Tango got enough. I don't know what these were. But yeah, these are like so these APIs are relatively new. A lot of it, this is of course things that have already been working with the Google image search and Google Photos, but as far as like web applications, there's not that much, like a whole array of things to show for right now.
Are the models behind the API continuously being
That is another good question. I don't know if they're continuing updating the model. Well, I would assume that as things that since a lot of these tools are still in beta, that they're continuing to work on updating the different APIs.
Let me ask a question about YouTube videos, like videos for machine learning. Google recently released YouTube 8M, which is a collection of 8 million YouTube videos.
Oh yeah, yeah.
So you can freely access that and go through it.
Yeah, it's done here. So yeah, this is on the Google Research blog. I was just looking at it. So for the video question, this is the new data set we used. All right. So if you want a business card, email me any questions and I'll be able to answer or find someone who can answer it for you.
Please pick up your stuff after you. There's trash bins on your way out. Thank you and see you next month.
Sure.